Show that the two figures are similar by identifying a sequence of translations, rotations, reflections, and dilations that takes the smaller figure to the larger one. Be as detailed as possible and impress me with your math vocabulary. Something to note is that the angle from each line coming out of point A is 15 degrees apart. So in this case here, we have 15 degrees between each of these lines. So to start us off, we notice two things about this offhanded. First of all, it's not in the same orientation, and what that means is that we probably are not going to translate it. But what we can do here is we can see that it is being rotated around point A. Now we just got to figure out, okay, how much is it being rotated? I'm going to pick two corresponding points to find out how much it needs to be rotated to land on the same line. I'm going to go ahead and choose D and D prime here, and I notice if I were to rotate this original figure, 1, 2, 3, 4 of these lines, it would land right where C is at, which is on the same line as D prime, meaning everything else would be rotated the same amount, 1, 2, 3, 4, 1, 2, 3, 4, and we would create this triangle here. So, well, what is 4 lines? Remember, each is 15. So 15, 30, 45, 60. So we are going to rotate it 60 degrees counterclockwise. But we're still not at the right spot here because we notice that it's a bit larger here of a triangle. Now, in this case here, again, because it's larger, we're making an enlargement, so we got to figure out what the scale factor is. In this case here, first of all, we see that I'm going to go ahead and call this D, even though it's not the original D. We see that D here is 1, 2 of these circles away, and D prime is 4 circles away. So, again, the distance from A here is doubled. The same thing can be said for this new C and C prime, right? So it's 1, 2 away and 4 away. So it's doubled. And again, with this new B and B prime, it looks like 1, 2, 3, 4 away, 5, 6, 7, 8. Did I do that right? Hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. So it's still double the distance away from the center. So what that means is that we're going to make a dilation around the center A with a scale factor of 2. And that would land us exactly on this triangle. So we rotate it 60 degrees counterclockwise. We have a dilation on the center A with a scale factor of 2.